Welcome. The next ideology that we are going to discuss is interval estimation of mu. So, as specified in the previous videos, this mu is the population mean. So, for this population mean, we were we were trying to find out the point value, that is the exact value of this mu, whereas in the interval estimation we will try to find out some interval in which this lie. Okay, so just recalling this one from the previous deductions, here just try to have this mu, there it is, and take everything else to the other side. That is what we are going to do is that here, out of which this mu is an unknown value, right? So the remaining things are kind of known to us. So when you take other things to the other side, you would get minus z alpha upon 2 product with sigma upon under root n is smaller than x bar minus mu smaller than z alpha upon 2 product with sigma upon under root n. Okay, now that we wish to retain this. Okay, from this, if I try to remove it, this is what is going to happen. Now let me multiply this throughout by this minus so that it becomes x bar minus z alpha upon 2 multiplied with sigma upon under root n smaller than mu smaller than x bar plus z alpha upon 2 product with sigma upon under root n. Okay, so this is with probability 1 minus alpha, and this, okay, this one we can put it as mu belong to x bar minus z alpha upon 2 product with sigma upon under root n comma x bar plus z alpha upon 2 product with sigma upon under root n. This mu belong to this interval with probability 1 minus alpha, and this interval is known as confidence interval, and this 1 minus alpha is the degree of confidence. Okay, and this is for the case when n is large. What if n is small? Instead of z alpha upon 2, we will have t alpha upon 2 with parameter nu equals n minus 1. This is the change that we have to inculcate in this interval. The remaining is same. Okay, so let us directly get into the problems. Here it is given that a random sample of 1600 leaves of a certain species had a mean length of 5.4 centimeters. So here n value is 1600, and it is given that the mean is 5.4 centimeter. If the population standard deviation can be assumed as, if sigma is 2.61, we are asked to find out 95% confidence interval, that is 1 minus alpha is 0.95. So from which we deduce alpha upon 2 is 0.025. Okay, so if we read the value of that alpha upon 2 from the table, it is 1.96 as we have done already. Okay, so the required confidence interval is what? X bar minus z alpha upon 2 multiplied with sigma upon under root n less than mu less than x bar plus z alpha upon 2 multiplied with sigma upon under root n, isn't it? So here this is going to be what? This mu will be in x bar value is 5.4 minus 1.96 into sigma value is 2.61 divided by under root 1600 comma 5.4 plus 1.96 into 2.61 upon under root 1600. So this is simply 5.27211 comma 5.52789. If you just do the calculations, you will get this one. Okay, and moving further, we have another problem. Here it is said that a random sample of 900 adults. So n is 900 in a large population has a mean height of 172 centimeter with standard deviation 32.1 and 1 minus alpha is 0.99. Okay, we are asked to find out the confidence interval. Okay, here your z alpha upon 2 is 2.575. By the same, like just like the previous cases, you can read this value from the table. Okay, therefore our mu will be in 172 minus 2.575 product with 32.1 divided by 30 comma 172 minus 2.575 into 30, sorry, here we will have plus divided by 30. Okay, and when you just perform the calculations you will get the answers. Okay, this is the simple ideology. Okay, and here also the n value is 16. So when n is smaller than 30, it is considered as small sample. Okay, therefore here we will have to make use of student t distribution. Okay, here n value is 16. Okay, after a certain grinding pulse after a certain length of time in a mill slurry is 3.42 gram with standard deviation. So it is given that x bar is 3.42 and sample thing is given to us, so it is 0.68. And what is 1 minus alpha? 0.99. So from which it is clear that alpha upon 2 is 0.005, isn't it? Okay. And what is new? This is n minus 1, that is 16 minus 1, which is 15. Okay. Now that we need to read this value. Moving further and checking in the table. So 0. Okay, let me choose different color now. So T 0.005 for new equals 15, right? So this is the value that we are looking for, 2.9467. So 2.9467, or that we will write it as 947. Okay. Now mu will be in what? X bar minus T alpha upon 2 product with S upon under root n, comma x bar plus T alpha upon 2 multiplied with S upon under root n. So mu will be in 3.42 minus 2.947 multiplied with 0.68 upon under root 16 comma 947 into 0.68 up plus under root 16. So when you simplify it, this you will get it as 2.92 comma 3.92. So the required confidence interval with 99% confidence is 2.92 comma 3.92. Okay, so from the next video we will start testing the hypothesis. Thank you.